Okay, here's a problem where x is approaching -3 from the negative side, in other words, from the left side of -3. And we're going to evaluate this limit of the absolute value of x plus 3 over x plus 3. Now let's just think about absolute values in general. They have this part of the definition. It assures that the absolute value will always be greater than or equal to 0. So in general, for the absolute value to be greater than or equal to 0, we must insist that the absolute value of some number k be equal to negative of k whenever k is a negative number. So when the trash inside the absolute value bars is negative, you have to say that the absolute value of that trash is equal to the opposite of that k. And think about the absolute value of -5. That's equal to the negative of -5, which is +5. And that's true because -5 is negative. Okay, that's the idea. Okay, now here our problem is that we're approaching x from the negative side. So x will be slightly less than -3. It'll be something like -3.1. And if that's the value for x and we put it inside the absolute value bars, we're going to end up with the absolute value of a number which is slightly negative. Okay, so because of that, we will use this rule that says the absolute value of k will be equal to negative k whenever k itself is a negative number. Okay. Now, establishing that, we can go ahead and evaluate the limit of this function. The limit, as x approaches -3 from the negative side of the absolute value of x plus 3 over x plus 3 is equal to the limit as x approaches -3 from the negative side of, now dropping the absolute value bars because of our argument above, this is negative parenthesis x plus 3 over x plus 3, which simplifies to -1. So this is a limit of x as x approaches -3 from the negative side of the constant -1. And you know the rules of limits, that just says that it's equal to the constant itself, -1.